Hello everyone, welcome back to RE Adventures. In today's video, we will solve some challenges from the Flaredle CTF. If you are not aware of Flaredle CTF, it is actually a reverse engineering focused CTF. In regular CTFs, we mostly get Linux or ELF files, but this is special because in this CTF, it is mostly focused on Windows stuff. All or most of the binaries that we get is of Windows binaries. So let's start with the first challenge, which is Flardle. In the description, it says that they have made their own version of Flardle, which we can play it here, and we have to cheat to win and get the flag. And we have some sources to download. So I have already downloaded that and extracted it, and we can see that we have some web stuff because we have the HTML, some JavaScript files, CSS file, and this is actually the source for this website that we have to from where we have to get the flag. So I opened the script.js because this is the most important script from this. So I was just skimming through and looking for what function could be interesting, and we can see that there is a check guess function which might be interesting. And because it's a first challenge, so it will be really easy. So we can already see that there is some right guess string, and later we can see that it actually compares whatever we input with this. So now we have two ways for solving this. First is statically. So for solving this statically, we have to check where is this variable assigned to. So if we would look at the top, we can see that it is assigned to words of correct guess, and correct guess is 57. And words is some array which is imported from the JS file that we saw earlier. So if we would open this words.js, so it actually contains words. It is an array of words. So we can say that we can deduce that at the index 57, counting from 0, the flag would be at the 57th index. So if we would go here and go to line number 58, because in Sublime the line numbers are from 1 and not from 0, and arrays are from 0. So at 58 we can see that there is some string. Flare on is all about cats, and this is actually the correct flag. We just have to append, let me copy this here. We just have to append at flare-on.com, and this is the correct flag. So this was one way of solving it statically. Now the other way for solving it dynamically. So let me go to the website again and let me open developer tools with Ctrl Shift I or F12, and in the debugger tab we can go here and we can put a breakpoint on check guess. So for putting a breakpoint, we have to click on the line number. I have already put a breakpoint at line number 60, and when I press enter, so now the breakpoint was hit and the debugger is waiting. So now we can see the same string that we just found with the static analysis, that flare on is all about cats, and this is another way of solving this challenge. So this was the first challenge. Now let's quickly solve the second challenge as well, which is Pixel Poker. And this challenge, I didn't actually do any reversing on this challenge. It was, if you have solved any steganography challenges, this was an easy challenge on the steganography side. So let me go to the directory of this. I have already downloaded this attachment, and in this challenge we just get the single almost 3 megabyte binary Pixel Poker. So first of all, it was the size was too large, so I thought like, okay, let's try to not solve this challenge. So first of all, I used 7-zip. So if you didn't know, that 7-zip can also parse ELF and PE files. Also, this Pixel Poker actually had a .exe. I removed .exe because I don't want to run it accidentally, because this is my main system. So if we would give 7c-l, -l is actually for listing whatever that binary or whatever that archive has. So if I would give Pixel Poker, then we can see that some information about the binary. First of all, that it is a PE file of 32 bits, x86 32-bit. And the interesting thing that I found was there were two BMPs. These are some icons which were not really helpful, but there are two BMPs, and they have the same size. So my initial thought was, let's actually see what this BMP has. So let me just create a temp folder where we can extract this, and let me copy Pixel Poker into temp. We can go into temp, and then I can do 7zx of this, and let me just delete it as well. So it extracted it. Now in the resources folder, we can see that there is a bitmap folder, and here we can see there are two BMPs which surprisingly have the same size. So let me open these with paint, and we can see some beautiful art. Is anyone surprised? And also the second one, 133.bmp, is actually similar, but not quite the same. So what my initial thoughts and experience from previous CTFs was that these two BMPs would be XORed or ORed, or its pixel values will be AND or something like that would happen. So I thought, like, let's just try. If it doesn't work, then yeah, we can fall back to reversing it and opening it in IDA. So I tried that, and I created a Python script for that. So here, yeah, you can see the flag here. So I used the pillow package which you can install with pip-m python-m pip install pillow. This is pillow. This is the package that I used. So I opened both of these BMP images, and this is the third image that will hold the XOR values of both of them. So I created a new image, and then for each and every pixel, I am for first image and second image, I am getting the pixel at each and every row and column, and grabbing their RGB values and XORing it. Like for example, R1 G1 B1 is for first image, and R2 G2 B2 is for second image. And then I just XOR the from both of the images, I XOR the red, green, and blue and stored it into RGB values. And then we can use the put pixel function to put this pixel values that we just XORed, this RGB, at some offset in the third image. So I use the width, height as the coordinates, XY coordinates, and put this value. And then I saved it into output.png. And then after running this script, we can see that this flag, yeah, this was the actual flag. It was actually hard to read here. Like for example, this was exclamation. I initially thought it was I or 1, but it was exclamation. Later I believe they changed this image, but when I solved, it was this image, and we got the second flag as well. Okay, so that's all for the video. Thank you for watching. Keep hacking and stay awesome.